Hey guys, I hope you all are doing well. Want to go ahead and get things started for the next unit. This is going to be an introduction. Next week you'll have more material, but I just wanted to introduce to you what we're doing coming up. So take a look. I'm going to go through the slide and then I will explain what you have to do as a follow up to the activity. All right, so the next topic is going to do or deal with probability. All right. So what is probability? Probability is, of course, the science of the likelihood of a chance event will occur. So the most common thing that we think about probability is the lottery. Like, what's the likelihood of winning the lottery? So who uses probability? So we all do in some form or fashion. The most common use of probability every single day is the weather forecast prediction. So when we check the weather, that means the weatherman has made a prediction based upon numbers in order to determine what the weather will be for that day. Is there going to be a chance of rain or how sunny it will be and so forth? So we use the weather to determine whether or not we're going to do things outside or whether or not we need to change the time of what we do out or when we do things outside. So we use probability on a regular basis just with that one particular topic alone, the weather forecast. So with that, I want you to think about how the probability of the weather is presented. How do they tell us the weather? So when do we use probability? We use it to make predictions of an event or a series of events that have more than one outcome. So for example, if you're thinking about winning the World Series for baseball, they take the numbers and crunch those numbers based upon the probability of their winning and who they won against and the points and so forth that they won by to predict who they think will win the series. We also use probability to figure out, how likely is it to win the lottery. We use probability to figure out which stocks to invest in the stock market or to predict any result of an event or a combination of events that have more than one possible outcome. Flipping a coin is even one. So sometimes those games that you speak of or that people talk about as far as probability, they are called games of chance. You will hear that as well. So how is probability calculated? So we have theoretical probability and experimental probability. So theoretical probability is the likelihood that an event will occur statistically. In other words, if everything is perfect, nothing's flawed. There is no there's no trick to it. So if everything is perfect, this is what will happen by numbers. Like, what does the number say? So think about a dice. If you roll a dice, we know we have numbers 1 through 6 on a die. If you on a dice, so if you were to look at the probability of rolling a 1, it's 1 out of 6. Look at probability of rolling a 2 is it's 1 out of 6. So therefore, that's by the numbers. What will happen by the numbers? Experimental probability is when you actually conduct the experiment in order to gather the data to make a prediction. So let's say you did roll a dice and you recorded how many times you got a number. So let's say you roll the dice and you got a 5. You got a 5 4 times. Let's say you roll the dice again, you got maybe 7. Not 7. Maybe you got 4 3 times or whatever it may be. So then you would say, okay, well, if you roll the dice, let's say you roll the dice 20 times, how many times did you get 5 out of the 20? That's experimental probability. In other words, you actually did the experiment and the results of your experiment, you use those numbers to make a prediction. So experimental probability and theoretical probability. In order to remember the difference, theoretical probability, in theory, what will happen? Experimental says, okay, what actually did happen? So why? Why is probability important? It is important because we use it to analyze data. Probability helps us to understand what can happen in an event, determine how we'll face or deal with the uncertainty of other events based upon the numbers. So, for example, we have an election coming up, and they have many different ways to analyze the data to make a prediction of who they think will win or who they think will come out on top. Um, Probability is used to make predictions. So determine what can happen if, or to see what options may have, one may have for certain events to happen in a certain way. So if someone is betting on the lottery and winning the lottery, what prediction can we make for that person to win the lottery? And then, of course, based upon that prediction, people start planning on what they would do if they win the lottery. And then also to justify outcomes. So in order to validate a prediction or a statement, we use probability by the numbers in order to justify the outcome. What did the data say about this prediction? What was the data saying as far as the decision you made? Why did you make that decision? Well, here's my information. Here's the probability of why, as to why I made that decision. So now, can you think of other reasons as to why we need and use probability in our lives? Do you know someone who has a career or a job that frequently uses probability? Think about those things. All right, so this chart here is to show you the probability of something happening by the numbers and by the percentages. So if you look here, probability and the likelihood. So if something has a 0 probability, we call that impossible. So 0 as a number is equivalent to 0 as a percent, so 0%. So if something has a 0 probability of happening, it is considered to be impossible. If it is, let's say, 25% or 0.25, here it has 0.2, so you can say 20% or 0.25, then we can say that it is, very unlikely, but it's not impossible. So, for example, if there's a 25% chance of rain, then it's not saying that it won't rain, but it's highly unlikely that it will rain. And then we have unlikely, which is more so, it's not quite as low as very unlikely, but it's not, equally certain. So that's around 0.4 as a number, as a decimal number, or 40%. Some charts do 0, 0.25, 0.5, 0.75, and then 1. So this chart is a little bit different, but the understanding is the same. If it is 0.5 or 50%, it is equally as likely that it will happen as it will not happen. So that's a 50-50 chance. You've probably heard it in that way, a 50-50 chance. And then anything between 0.5 and 1 is going to be considered to be likely. So like, let's say 0.75 or 75%, it's not certain, but it's not going to be equally likely either. So it's a little bit more than equally likely, but it's not certain. When you get to 1 as a number or 100%, then we call that certain. It will surely happen if it is a number 1 or 100%. So the numerical equivalent of probability is either from 0 to 1 or from 0% to 100%. So there are two types of probability, and we've already mentioned them before, but we're going to look at them in a little bit more detail. So as we said before, theoretical probability is what should happen in an event based on the number or the mathematics of the event. So here's a table. It's not as clear in the print, but you can see that theoretical probability is what should happen during the event. So if I have a number cube or a dice, and I have the numbers 1 through 6, that means every single number has a 1 out of 6 chance of happening. If I have a coin, so we have a heads and a tails, that means that every time I flip the coin, there's a 50% chance I'll get heads and there's a 50% chance I'll get tails. That's in theory, without even flipping the coin. If I have here I have a spinner, that's what it's called, a spinner. And I have, in this case, there are 8 equal sections. It looks like 1, 2, 3, 4, yeah, 8 equal sections. So half of them are even and the other half are odd. So it will be a 50% chance of getting an even number on your spin and a 50% chance of getting an odd number on your spin. That again is in theory, which means we do nothing. We have not actually rolled the dice, we have not flipped a coin, and we have not spun the spinner. We just say, based upon what we know, this is what should happen. Now we have the experimental probability that we talked about before. So in this particular diagram on this table, we see that there are different colors: white, orange, red, yellow, black, and purple. So evidently this might be a spinner with different colors on them, or it could be, in this case, maybe some marbles, or it says jelly beans. So when you're actually having a bag of jelly beans, you pick out a jelly bean each time, and you record what color you pick out when you pull out the jelly bean. So you're actually doing the experiment. You're conducting the experiment to see the results. And so the numbers that are written here, the 4, the 7, 5, and so forth, are the results of getting a white jelly bean, getting an orange jelly bean when you pull it out. So when you find the experimental probability, it is the number of times the event occurred. So if I want to see how many times I got an orange, so then I would say, okay, well, I got orange 7 times, so that would be my numerator number, over the total number of times I actually did the experiment. So to get the total, I would do 4 plus 7 plus 5 plus 7 plus 6 plus 3 to figure out how many times I reached in and pulled out a jelly bean. In this case, it is 32. So I would do 7 over 32 to determine the likelihood of the event of getting an orange jelly bean. Okay. If I wanted to do red, I would do 5 over 32 to figure out the probability of picking a red jelly bean. Okay. So that's the difference between experimental and theoretical. All right. So some probability examples that are common in our everyday world. We have, of course, if you have a deck of cards, picking a red card from a deck of cards. If you know about cards, half of the deck is red, half of the deck is black. So that's one thing we can look at. Now, you may not play cards every day, but remember, we have casinos across our country in different places where they operate every single day. So somewhere, somebody's thinking about that in reference to them winning a game that might be at a casino. Tossing a coin to see how many times it lands on tails or how many times it lands on heads. So we know in football, they do a coin toss in order to determine who gets the ball first and who's receiving first. So even though it's not a probability problem, it is based on the likelihood of it happening, which should be 50-50, but we know it doesn't always end up being 50-50. Another one, picking a blue marble out of a bag of red, blue, green, and yellow marbles. So let's say you're playing with your younger sibling, you have a bag of marbles, and you're picking them out. That's an everyday world problem. And you may not think of it as being probability, but really it is, because you're picking out marbles and you're looking at how many times you are getting a particular color. And another example that I have, not the last, but another one, let's say you play basketball. So making a 3-point shot out on the basketball court during practice. If you are trying to increase the likelihood of you making that shot, then you're going to practice that particular shot in practice to figure out how many times you actually make the shot out of how many times you shot that shot. Let's say you do 100 3-point shooters in practice every single time you practice. Out of that 100, how many are you making? And of course, the higher that number is of the number that you make out of 100, then the more likely it is that you'll make that shot in a game. All right, so now we're coming down to the end of the slide. Here, I want to know what some of your ideas are about how to find the probability of an event. So you're not going to write on this slide, but you will write on a slide just like this from Google Classroom. So this is your practice assignment for the lesson. So what I want you to do is to add your own ideas to the Google slide from Google Classroom. And you'll find it as an assignment in the classwork tab in Google Classroom. Once you open up the assignment, when you click on the Google slide, it'll open a copy for you. Type in it and then submit when you're done. Hopefully it won't take you much more than maybe 2-3 minutes to do this because you have ideas already. but that's your only assignment from this lesson, is to do that, as well as one more thing, which I'll mention in class when we have a live Google Meet. So that's the end, guys. I am so proud of you all. I'm very, very proud of you all for making a choice to continue learning. I am certain that it's not easy to do that at home with so many other distractions, that you would like to do, be it sleeping in, do nothing, watch TV, Netflix, whatever it is that are your distractions. I know it's not easy to continue learning under those distractions. So I am very appreciative of your efforts, and I am deeply moved by your dedication to still learning. It takes a lot to do what we're having to do under the circumstances we are in. So I am really, really thankful and appreciative of your dedication. So I thank you for that. All right, guys. If you have any questions, you know how to reach me. Thank you for being a part. You can schedule a time to meet with me during my office hours or anytime on Monday, Tuesday, or Friday. Remember, we don't have a Google Meet session, a live session on Mondays or Tuesdays. So I'm typically available just about all day if you want to talk to me or have questions. Here's a link for signing up on the Google form, or you can send me an email. Okay? I'm accessible, so just make sure you reach out to me and I will help you any way I can. I would love to help you if you should need it. All right, guys. Thanks. Bye. Go to Google Classroom and check out the assignment, as well as the other assignment that you have that will be due on Tuesday. So you have two assignments that are coming up. One is due, I think this one's going to be due, I believe, Saturday, and then the other one is going to be due on Tuesday. So you'll see it in Google Classroom. All right, guys. Bye.